Good morning. My name is Gaurav Singh Rathod from Institute of Aeronautical Engineering. Today we are going to discuss the topic band theory of solids, which is from Applied Physics. The subject code is AHSC09. So let us see. So in what is in solids, the atoms are arranged in a symmetric space lattice, and each atom is influenced by neighboring atom. The closeness of atom results in the intermixing of electrons of neighboring atom. See, we can see this. Next is the introduction. So we are going to see the introduction of band gap. So we can see that silicon has 14 electrons. It's 1s2, 2s2, 2p6, 3s2, 3p, which has 4 valence electron. Electron present in the outermost orbits are called valence electrons, and the behavior decides electrical characteristics of materials. For silicon, 2 electrons are present in 3s and 2 electrons are present in 3p orbitals. Consider ns atoms which are from parts from which each other that the interactions between them is negligible. In this 2n occupancy, the 3s level and 2n electron in 3p level. When the atoms are brought to closer, the interaction between increases and they now form an electron system. You can see the electronic system should obey Pauli's exclusive principle, which states that no electrons are in a system have same amount of energy. So to obey this 3s 3p levels split into multiple levels so that each electrons can occupy a distinct energy level. So when interatomic distance is further reduced, the 2n level and SNP level combined into a single band. At lattice space, single band is splits into two bands, with upper band containing 4n and lower band containing 4n levels. At 100 K electron pressure, lowest energy, they filled up with valence electron. So this is the gap in conduction band and valence band. So like this, it allows the energy. So this is this diagram of energy band. This is isolated atom when with it, it there is a discrete energy level in case of an isolated atom. These are 1, 2, 3, 4 and 5. So what are energy band gaps? There are three important bands in energy: valence band, conduction band and forbidden band. See, we can see this. So we will discuss about these in details about the band theory. So what is valence band? Band of energy level which are closer to the nucleus, and an electron in valence band experiences strong force of attraction from nucleus of the atom, and it can't move freely when external electric field is applied. It is called bonded electron. So what is conduction band? Bond of energy level which are far away from nucleus. This is the valence band is closer and this is far away from the nucleus. The conduction band is the band of orbitals that are high in energy and are generally empty. An electron in conduction band has weak influence of nucleus and hence it can move free under the effect of applied electric field and thus is produce current. It is called free electrons. Now forbidden band or energy gap. In solid states physics, an energy gap or a band gap is the energy range in a solid where no electron states can exist. In general, it refers to the energy differences between the two top of the valence band and the bottom of the conduction band in an insulator and a semiconductor. So we will see this in the materials. So the materials are divided into three types: insulators, conductors and semiconductors. So insulators are materials which have very large energy gap. We can see electron volt 1.6 into 10 raised to the minus joule 19 joules. We know that due to the large energy gap, an electron from valence band can't move into a conduction band and remains completely filled. So in this, there is no jump of electrons because there is a huge gap, so conduction band completely empty. So some examples are glass, diamond, silicon dioxide. Energy gap of diamond is 6 electron volts. Next are conductors. Conductors are the material which conduct electricity. It is a material having zero energy gap, the material in which conduction and valence band. Valence electrons can move from valence band to conduction band without requiring any thermal energy. So the overlapping indicates a large number of electrons available for conduction. Hence, the application of a small amount of voltage results a large amount of current. So some examples are metals. Best conducting materials are silver and copper is the second best. So next is semiconductors. The materials in which the conduction and valence bands are separated by a small energy gap, that is 1 electron volts, are called semiconductors. So some examples are silicon and germanium are used as semiconductors. A small energy gap means that a small amount of energy is required to free the electrons by moving them from the valence band into the conduction band. So the semiconductor behave like insulator at 0 Kelvin temperature because no electrons are available in the conduction band. If the temperature is further increased, more electrons will acquire energy to jump into the conduction band. So we can see this diagram. See, in insulators, we saw that wide energy gap is there from valence band and conduction band. So no electrons are transferred. So in conduction, very small. So the overlapping is we can see. So in semiconductors, we can see energy gap is very less. So it can transfer electrons easily. So next we will see what are direct and indirect band gaps. The process of free electrons returning from conduction band to a valence band which causes disappearance of a free electron hole pair is called carrier combination. So these are divided into two types. One is direct band gap in semiconductors and second is indirect band gap in semiconductors. Now we'll see direct band gap. For these semiconductor, conduction band minima and valence band maxima occurs at same value of momentum. So the momentum value is same, you can see in the diagram. An electron from conduction band directly returns to valence band without changing its momentum. So and release energy in the form of light. Example, photons. Photon HV. So example are gallium arsenic gap and gallium arsenic phosphorus gap, etc. So next is indirect. In indirect, minima and conduction band minima and valence band maxima occurs at different value of momentum. When electron from conduction band returns valence band after changing its momentum is called indirect band gap. See, this is returning from conduction band to valence band. So electron changes its momentum by releasing photon, which is a heat particle. It's phonon. So you can see there's the difference is in direct there is no change in momentum, but in this there is a change in momentum. Examples are silicon and germanium. So n-type semiconductors are these are fifth group elements like phosphorus, arsenic. So phosphorus forms 4 covalent bonds with silicon and donates 5 electrons to crystal. It is called free electron. See, according to the law of neutrality, Np is equal to Pn plus Pn. Nd, mass action law it is. So majority is electrons, minority is holes. So this is minority. P-type semiconductors. In P-type, example are third group like boron, aluminium, gallium, So it forms 3 covalent bonds with silicon and forms 4 bonds with hole formation according to the non-neutrality Np plus Na is equal to P. So majority is holes and minority is electrons. So this is wise. So with this we end our discussion regarding the gap band gap of solids. So thank you.